see about sedimentation. So sedimentation is nothing but settling of particles. And this rate of sedimentation depends on the speed, that is velocity. Rate depends on velocity. So there, as I said, there are two methods. One is sedimentation velocity and the other one is sedimentation equilibrium. So with this sedimentation velocity and sedimentation equilibrium, we can calculate the molecular weight of a given particle. So first we will see how to calculate molecular weight with the help of sedimentation velocity. So you all know this sedimentation velocity or centrifugation depends on mainly force. So here in this case two forces act. One is buoyant force, the other one is frictional force. So buoyant force and frictional force play a major role in case of sedimentation. So how will you write this buoyant force? Okay, in general what is the equation for force? F is equal to ma. So same is applied here. Here buoyant force is equal to, what is m? M is nothing but mass. So it is written as mass of the particle. Mass of the particle minus, since it is buoyant force, here buoyant factor is involved. So instead of mass, here mass of the particle minus buoyant factor into acceleration. Here since it is centrifugation, gravitational force plays a major role. So A is replaced with G, that is acceleration due to gravity. Okay, so now mass of the particle, you know, density is equal to mass by volume, right? So in order to find mass, it is density into volume, which can be written as, density can be written as D and volume is V. So volume, so this equation for mass, it can be written as volume is nothing but 4 by 3 pi r cube into density. Okay, this is mass of the particle. In case of buoyant factor, it can be, for buoyant factor can be written as same 4 by 3 pi r cube into, instead of d, it is d dash. D dash is nothing but density of the solvent which we use. So this buoyant force can be written as 4 by 3 pi r cube d minus 4 by 3 pi r cube d dash into g, acceleration due to gravity. So this can be simplified into 4 by 3 pi r cube g into d minus d dash. So this is the buoyant force. I can keep it as equation 1. Next is frictional force. Next is frictional force. This is written as 6 pi eta, which is constant, r into v. So now equating both the forces, frictional force and this can be written as equation number 2. So equating equation 1 and 2, you get by 3 pi r cube g d minus d dash is equal to 6 pi eta r v. So here our main aim is to find the sedimentation velocity. Here v is the sedimentation velocity. So now solve this equation. V is equal to, keep v alone this side and bring all the rest to the other side. So 4 by 3 pi r cube g into d minus d dash divided by 6 pi eta into r. So by solving this equation, you get 2 pi r square g d minus d dash divided by 9 eta. Pi gets cancelled. So this is the formula for sedimentation velocity. So where g is the acceleration due to gravity, r is the radius, d is the density of the particle, and d dash is the density of the solvent. So by knowing the sedimentation velocity and density, we can find the radius. So how to find this v? So you all know what is velocity. Velocity is nothing but distance by time is nothing but velocity. So here we can mention distance as x and time as t. So for example, during centrifugation, the distance travelled by the sample from top to bottom, it can be written as x1 and this is x2. And the time taken for a sample or a particle to move from upper to lower is, here it can be written as t1 and this is t2. So x1, x2, this difference can be written as dx, and t1, t2, this difference can be written as dt. So this is v. Okay, now you got v is equal to dx by dt. So substitute v in this equation number 3. So if you substitute, what happens? Dx by dt will be equal to 2 pi r square g d minus g dash by 9 eta. So in order to solve this equation, we need to integrate that on the distance travelled, I told you x1 to x2 and t1 to t2. So on integrating this equation, dx x1 to x2 is equal to dt will go that side. So 2 pi r square g by 9 eta into d minus d dash is constant. So integrate dt. It is t1 to t2. So you get x2 minus x, because integration of dx is nothing but x by substituting the limits, upper limit minus lower limit, which is equal to 2 pi r square into g by 9 eta into d minus d dash t2 minus t1. Now you will know the distance, you will know the time, and you all know the density. So with the help of this, you can calculate the radius of the particle which we want to separate. Now we can find the r. So r can be calculated using the above equation. But our aim is to calculate the molecular weight and not the radius. So in order to calculate the molecular weight, we need to find the mass of the particle. So what is the formula for mass of the particle? As I said earlier, m is equal to 4 by 3 pi r cube. So with the previous equation, you can calculate radius, that is r, and this r is again substituted here. You will get the m value, mass. And from this, molecular weight can be calculated. Molecular weight is nothing but n into m. N is nothing but the Avogadro number, which is constant. Okay, so if we all know n and m can be calculated from the above equation, from this molecular weight of the particles can be found, and this is for larger molecules. And for smaller molecules, in case of ultracentrifugation, the only difference is here, instead of acceleration due to gravity, it is replaced with omega square r. Omega is nothing but angular velocity. Omega is nothing but angular velocity. So substitute here, instead of g, if you substitute omega square r, this equation will be applicable for smaller particles. So now with the equation we can calculate the molecular weight of the particle, and this molecular weight is of two types. One is number average molecular weight. Number average molecular weight. The other one is weight average molecular weight. Okay, so this number average molecular weight, which can be written as mn bar, it can be calculated if we know the number of molecules and the molecular weight of the molecule divided by, with this formula you can calculate the number average, and the other difference is same formula but the difference is instead of number of molecules, if you know the concentration you can calculate the weight average, that is is equal to summation Ci mi square by summation Ci or summation Ni mi square by summation Ni mi. So this can be calculated either you know the concentration or the number of molecules present in the sample. So with this you can calculate the number average molecular weight and weight average molecular weight. So I will solve a simple problem related to this. So for example, you have a polymer and the molar mass distribution, you have two molecules N1 and N2. N1 is around 50 moles and the N2 keep it as 70 moles. And the molecular weight of this is around 2000 daltons, and for this you assume it as 5000 daltons. So how will you calculate the number average molecular weight? So the formula for calculating number average molecular weight is sigma Ni mi by sigma S. So this is the formula. So when you substitute, it is 50 into 2000 plus 70 into 5000 by 50 plus 70. So when you solve, you will get the answer, that is the Mn, that is number average molecular weight. Similarly, in order to calculate the weight average molecular weight, you need to just square of molecular weight. Here 50 into 2000 plus 70 into 5000. You will get the weight average molecular weight. So with the help of sedimentation velocity, we can calculate the number average we can calculate the molecular weight and also the number average molecular weight and weight average molecular weight. Thank you.